In order to understand recursion, first we need to understand recursion. That was actually the joke. But the definition of recursion is pretty simple. The process in which a function calls itself directly or indirectly is called a recursion. Let's take a look at a very simple example. Can you tell me how many times increment function would be called? You can see that we have a function, and inside the function, well, we are calling the function again. So can you tell me how many times? If you guess infinite, then that's pretty true because, well, there is no way to get out of that particular loop. Increment is just calling increment. So a function is calling itself again and again and again and again. So let's look at different cases of a recursion or recursive function. In order for a recursive function to work correctly, it should have two different cases, the base case and also the recursive case. The base case is a case which actually ends the recursion. And the recursive case, which we have already seen, is a case which calls the function recursively. Now let's go back to the code and see if we can spot the recursive case as well as the base case. So here's our function. That's the same exact function that we started with. You can see over here, this is the recursive case. Can you see any base case? Can you see any code that can end this function from going in the loop and again? I'm talking about the base case. Can you see any base case which will end the recursion? No, we can't. There is no base case in this code. Let's take a look at another piece of code in which we will find out and we will point to the recursive case as well as the base case. First of all, the recursive case. This is easy to spot because we are calling increment inside the function increment. So that will be our recursive case. Then our base case would be the case that is going to end the recursive behavior. And that if condition is our base case. Whenever you are doing recursive or calling functions in a repeated manner recursively, you also need to know about the call stacks and what happened behind the scene when you are calling functions again and again and again repeatedly inside the same function. For this to work, let's consider a very simple example. Let's go ahead and create a factorial application and see how that actually works. You can see at the end I'm passing 5 as a number and trying to calculate the factorial of 5. Now, for those of you who don't know what factorial is, a factorial is basically a number multiplied by all the previous numbers greater than 0. Obviously, if you multiply by 0, it will be 0. So a factorial of 5 is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. A factorial of 3 is 3 multiplied by 2 multiplied by 1. All right? Okay. So let's see how we can create a factorial application using recursion. You can see that we are passing 5. So 5 is going to go. 5 is first of all going to be checked that if 5 is equals to 0 or not. That's our base condition. If number is equals to 0, number is not 0. Number is 5. So that's definitely not 0. So it's going to completely ignore that if condition. Number is 5. And here what we're going to do is we're going to call the factorial function, which is itself, again. But this time, instead of passing 5, we're going to pass in the number, which is 5 minus 1. And at that point, a stack will be generated. And in the stack, what we're going to do is we are going to put this line, the line at which the call was being made. It was 5 multiplied by factorial of 4. Because at this particular moment, when we pass in 5, it's still waiting for a factorial of 4 because it just called the factorial of 4 function. So let's see what happens when factorial of 4 is getting called. Okay, so now 4 is going to get passed. 4 is not equal to 0, so our base case is never satisfied in that case. Number is 4. And now we are going to pass in another call, and we're going to call it factorial of 3. And the whole line is going to move into the stack. All right, so now we're passing 3. So if 3 is not equal to 0, so base case for our recursive is never satisfied again, we are going to pass in 3, and we're going to pass in factorial of 3 minus 1, which is 2, and then put that in the stack. Because that call is now waiting for the factorial of 2 call. Once again, we're going to pass in 2. 2 is not equal to 0, so it's not going to do anything. And then factorial of 1. And then this call is going to be added to the stack also. Next up, we're going to pass in 1. 1 is not equal to 0, so again, it's not going to do anything for the base case. We're going to pass in number 1, and then finally, we are actually going to pass in factorial of 0. And then put that in the stack. Let's go ahead and pass in 0. Factorial of 0 is 1. We already know that because that's the base condition, and that is going to end our recursive behavior. Now we know that the factorial of 0 is 1. We start going back on the stack and filling out all the blanks. So factorial of 0 is 1. That means factorial of 1 is 1 multiplied by 1, which is 1. Now we know factorial of 1. Guess what? 2 multiplied by factorial of 1 can be replaced by the value of factorial of 1, which is 1. So factorial of 2 becomes 2 multiplied by 1. Guess who needs factorial of 2? You guessed it, it's 3 multiplied by factorial of 2. So that will be 3 multiplied by 2. Guess who needs factorial of 3? Yep, 4 multiplied by factorial of 3, which in this case will be 6. So 4 multiplied by 6. And finally, 5 multiplied by 24 coming out to be 120, which is the factorial of 5. So this is how we use recursive functions to generate the factorial. Now, anything that can be done with recursive behavior or with recursion can be done by using while loops or not using recursive functions. But you will find out that usually things that you're trying to do using recursion end up with very few lines of code as compared to if you are not using recursion. If you're talking about the performance, then the performance will not really matter in both the cases. Usually, actually, if you don't use recursion, those things might be a little bit more faster than if you do use recursion. So performance is really not the benefactor for using or the criteria of using recursion. All right. So the main benefit of recursion is that you will end up with less lines of code. All right. So now that you understand recursion, let's go ahead and implement factorial in our playground and see how it works.